Hi everybody. So we are back into our third lecture on signal and system. So we have done a couple of lectures on signal and system, and we have done, in fact, a great deal of revision on signal and system, right? So we have started with the continuous time signals, and we have been talking about basics. So I hope many of you might have got new insight of solving questions. Okay, so. Uh, Today again I will be talking about continuous time only, then we will start the discrete time. Okay, so I know, I can understand you might be facing a lot of challenges on discrete time, as well as you might be lacking. So like you might be lacking lot everywhere. I'm pretty sure, because the concepts are not taught properly in all the institute anywhere you take classes, right? So partial information is given, like suppose you have to find the energy of a signal, so they will directly give you the formula for energy of a signal, but they will not talk about how formulas are, you know from where you got the formula, right? So in this session I'm going to talk about everything, like, so all these sessions are very important, so please follow them honestly, right? So these all sessions are being streamed from Bangalore, guys. So it's a great chance if you get a complete insight and get a good rank in gate examination. Join ISC Bangalore, and you can also meet me, right, in Bangalore, right? So chalo. So let's start the session here without further ado. This is going to be L3 here, and in the last session I talked about various things. I talked about symmetries, the concept of symmetry basically. Hi Subham. So in the last session, I talked about symmetry, and I hope you might have got some new insight. Even symmetric, odd symmetric, half-wave symmetry. Half-wave symmetry is only defined for periodic signal, right? So those concepts are very useful when we will talk about Fourier series. Okay, so please do follow them. Fine. So in this session, what I'm supposed to talk here is, suppose you have got a signal, right? Suppose you have got a signal, okay, like combination of sinusoids, if I talk about. So combination of sinusoids, okay, and these are very popular questions, right? Combination of sinusoids, okay, will be given. You can say that by t is equal to x1t plus x2t plus x3t, okay, plus and so on, right? So each suppose this is one sinusoidal, you can say it has got omega 1 frequency, it has got omega 2 frequency, you can say omega 3 frequency, right? Or you can also find the t1 time period, corresponding time period t1, and the corresponding time period t2, and corresponding time period t3, right? So in case of continuous time signal, as far as the if suppose you have been given a continuous time sinusoidal signal, okay, so you can directly say that that will be always periodic, right? But suppose combination is given, right? There are many sinusoids are given, right? Okay, having different frequency, okay, having, you can say, harmonics are given, and corresponding frequencies are given. You can find out as well as the time period, okay, individual time period. But they will ask what is the fundamental frequency of this combined combined sinusoids, or they might ask what is the fundamental time period, right? So how do we find out that? Okay, that first of all, whenever combination of sinusoids will be given, so you have to examine whether the given combination of sinusoids is periodic or not, right? So you have to first check whether the given sinusoids is periodic or not, right? That is very important to keep in mind. Yes. So what are the steps that you have to follow, that let me tell you. Okay, so first of all, what you have to do before you start computing the time period, okay, or a fundamental time period, right? Or you can say that fundamental frequency, right? If you are able to find fundamental time period or fundamental frequency, then you are able to find the fundamental time period. See, given a combination of sinusoids, by looking at the sinusoids, combination of sinusoids, you can decide that, yeah, this signal is periodic or not. But that is by inspection you can answer, but I will give you some some kind of steps that you have to follow, right? So what you can do here is, you have to make sure that you have to make sure that what the very important step that I'm gonna tell you now is what you have to make sure that when the ratio of each pair of individual frequencies or a period you can say is rational fraction, you can say, right? You can say that the very first is you have to determine frequency, individual frequency omega 1, omega 2, omega 3 and so on, and then you can also determine T1, T2, T3. Then you can check this, okay, like you can check omega 1 by omega 2, right? Omega 1 by omega 3 and so on, right? You can check this, okay? So take the ratio of these frequencies, okay? Take the ratio of these frequencies when the ratio of each pair of individual frequencies is irrational, okay? Or you can say that T1 by T2, okay? T1 by T3 and so on, like this you can find out, okay? Just take the pair, okay? Take the ratio, and these ratios should be a rational number. These ratios should be the rational number, okay? Rational number, understand? So what is the meaning of rational number? That we have to understand. So rational number is nothing but what? So let me write this statement. This statement is very, very important. So when you can say that a signal is periodic, okay, the combination of sinusoids is periodic, or sometimes we call it harmonic signals, right? Combination of sinusoids is nothing but what? Harmonic signals, right? Sum of harmonic signals, okay? So when ratio of each pair of individual frequencies, when ratio of each pair of individual frequencies, right? Or you can say time period, right? Coming out to be what? Rational number, you can say rational number, okay? Then you can say that the signal is periodic. Then we will say that the given combination is periodic. Given combination is periodic, right? That is for sure. You have to first check, right? This is very important step. So what you can do here is this is one of the very important step, right? So if you claim that the given sinusoids is periodic, right? So then what you can do, how can you find the fundamental frequency? You can find the fundamental frequency just by taking the GCD of that. Omega naught is nothing but GCD of omega 1, omega 2 and so on, okay, like this. Or you can also find the fundamental time period by taking LCM of T1, T2 and so on, okay? So this is the step that you have to follow, okay? If you want to find the fundamental frequency, so you have to find the GCD. I think GCD everybody knows, right? GCD is what? GCD is nothing but the highest common factor or greatest common divisor, right? Okay, greatest common factor, or you can say that greatest common divisor or highest common factor, right? So this is the direct step that you can apply, right? I hope this makes sense. Okay, understood. So this is very important step that you can follow. So let me put this in a proper manner, right? So this is very important question that people can ask, right? In mainly in ISRO you can find out question, also GATE, right? So what I want to say here is that you see this is very important concept. When is the sum of sinusoids like by t equal to x1t plus x2t is periodic? So this is the first step that you have to perform. The ratio of each pair of individual frequencies or periods is rational number or rational fractions, you can say, if periodic, okay? If periodic, if this is the first case that the combination of sinusoids has to satisfy. अगर ये पहला स्टेप आप मतलब satisfy होता है, ठीक है, then you have to find fundamental frequency. If combination of sinusoids is not periodic, then you don't have to find fundamental frequency, right? Okay, that is for sure. And there are some shortcut that you can use to determine the fundamental frequency. So f naught is given, f naught is what? GCD of individual frequency. F naught is nothing but what, right? So one question was also there in GATE 2013, okay, that I can directly take, okay? So one question was there, understand? to determine the fundamental frequency directly, right? So we can directly take that question also if you want. Okay, so and I can show you, yes, but I will take some other question. So this is all about periodic signal, right? Combination of sinusoids, whether it is periodic, and how do we determine common period, or you can say the fundamental frequency. In case of fundamental frequency, you have to take SCF or GCD, right? And in case of you can say that common period, you have to do the LCM of individual, right? So suppose you have been given a combination of sinusoids at a different frequency, right? So how do we find out the RMS value or something, right? So you can find the RMS value just by taking what? You just find the individual power, okay? Individual power, right? You can say P1, P2, P3, P4, and then you take the square root of that, right? So the for combination of sinusoids at different frequencies, say by t equal to x1t plus x2t, the signal power by P by equals the sum of individual powers, okay? Sum of individual powers. And what is the relation between power and the RMS value? You know that RMS is nothing but square root of the power. Okay, that is very, very important to keep in mind. Okay, fine. So if any signal is not periodic, then you can say that that signal is going to be what? Aperiodic, or sometimes we call it almost periodic signals, right? So let me take one question here. You know, the question says that, you see here, the question is nothing but what? Xt is equal to 2 cos pi t plus t. Suppose only one sinusoidal is given, so you can say this is periodic, right? But one more sinusoidal is given, suppose sine of 3t. Now by looking at this, can you say that is it periodic signal? Sometimes we call it almost periodic signal, or we have to check. So what we can do here is, what is omega 1 from here? That is pi. What is omega 2 from here? That is 3. So if you take the ratio of omega 1 upon omega 2, which is coming out to be pi by 3, and pi by 3 is not a rational number, right? Not a rational number. Why? Because the pi is a irrational number, that everybody knows. The pi is what? Irrational number, you can say. Okay, so by looking at the individual frequency, you can decide whether it is going to be a periodic or not, right? As far as the periodic signal is concerned, the ratio of individual frequencies or the time period, right, should be what? Rational number. Understand? Now it is not periodic. Not periodic. Okay, so you don't have to find fundamental. Okay, you don't have to find fundamental frequency. In fact, you cannot find it. You see here, suppose I want to find omega naught. So GCD of pi and 3. So nothing is common between this, right? Nothing is common between this. Okay, so don't find it. Okay, so if, as long as the given signal is not periodic, then you don't have to find fundamental frequency or a fundamental time period. Okay, this is very simple. Sometimes we also call it sometimes we also call it what? Sometimes we also call it almost periodic signal, right? So this is very important concept that you have to remember. One more concept is there, as I told you. This is also used in network theory. Okay, so this is very important question, right? Suppose you have to find power, okay, power or something, okay. So we always compute what? IRMS, right? In case of AC circuit analysis, right? So at that time we need this kind of a concept, right? So the signal power adds for a sum of sinusoids at a different frequency. You have to make sure that they have different frequency. You can say omega 1, omega 2, right? So you can just find out the power. So Py is going to be what? Px1 plus Px2 plus and so on. And if you want to find RMS, so RMS is nothing but square root of Py, right? So these are the formulas you have to remember, okay? Provided all the sinusoids should have different frequency, है ना? याद रखना, different frequency होनी चाहिए, okay? तो ये कॉन्सेप्ट है, इसको आप याद रखो क्योंकि ये नेटवर्क थ्योरी में भी काम आएगा. मैंने आपको बताया था कि सिग्नल प्लेज एन इंपॉर्टेंट रोल इन नेटवर्क थ्योरी, इन इलेक्ट्रिकल इंजीनियरिंग, इन इलेक्ट्रिकल सर्किट्स एज वेल, राइट? चलो ठीक है, एक क्वेश्चन लेते हैं, वेरी इजी क्वेश्चन आई एम जस्ट गोइंग टू टेक. सपोज वी हैव गॉट अ सिग्नल, right? Let me take one very simple question, that is periodic combination only. We have to check whether the given signal is periodic or not, right? So let me take that question. Okay, so the question here is nothing but this, okay? Let me consider this signal. Okay, consider this is first question. consider xt, okay, 2 sine 2 by 3t. Yes, so by looking at this you can say that, see, this phase does not affect okay, there is a phase also 1 by 5 pi, right? It does not affect the periodicity, remember, okay, phase does not affect the periodicity, okay, because this phase comes because of the time shift, you can say, right? Okay, now you have to only focus on individual frequency. You can say omega 1, there is omega 2, there is omega 3, right? So all frequencies are, you know, like different only, and they are fractional, you know, already frequencies are given in fraction, 2 by 3, right here, 1 by 2, and this is 1 by 3, right? So how do we find out? See, as long as we can see here, if you take the ratio of omega 1 by omega 2, omega 1 by omega 3, right, or omega 2 by omega 3, or omega 3 by omega 1, all the permutation combination you can check, right? Matlab ratio of individual frequency you have to check, and that should come out to be rational, right? Rational. If you don't have any idea about rational, what is rational number, right? I will discuss rational number in our coming aptitude course, right, which is going to be in this YouTube channel only, right? So that is very important. So if you take the ratio of these, so yeah, first step is done. It means this guy is what? Periodic. So this guy is periodic. Now you can find the omega naught. Omega naught is nothing but what? GCD of the fractions, 2 by 3, 1 by 2, and 1 by 3. So I'm pretty sure that you know how to find HCF of any given fractions, right, or given rational numbers. So what is the HCF here, guys? GCD of, you know, if they are asking GCD of this, so first of all you have to find GCD of 2, 1, 1, and then you have to find LCM of 3, 2, 3. This is the way we find out GCD of any fractions, right? So what is GCD of this? You can say that GCD is nothing but 1, right? 1 is going to be GCD, and what is the LCM here? So LCM you can find out quickly, right? So LCM is gonna be nothing but what? What is the LCM in this case? Okay, so you guys can find out LCM quickly, right? What is going to be LCM? Yes. So LCM will be nothing but 6, right? So you can say that 6 is the LCM. So what is the omega naught? Omega naught is nothing but 1 by 6 radian per second. Now you can also find the what? Time period, which is nothing but 2 pi by omega naught. That is 1 by 6, which is 12 pi. 12 pi. Okay. So 12 pi is going to be the 12 pi second, you can say 12 pi second to be very specific. Okay, this is the fundamental time period, right? So always remember, these are the concepts that you have to remember. What are the concepts? How to find GCD of, you can say that P by Q, A by B, and X by Y, you can say. So you can say that first take GCD of P, Q, X, numerator ka GCD लो, and LCM of A, B, by. This is called. And suppose you have to find LCM of P by Q, A by B, and X by Y, you can say. So if you are finding LCM of a fractions, so first take LCM of numerator, right? Then take GCD of, okay, that's it. Okay, so this is how you can find out the time period. It is very important concept that you have to remember, right? Fine. So these concepts you have to remember, and if you want to find the power, so power you can quickly find out power as well. Power is nothing but, first of all, find power. So individual power you have to find. Okay, so individual power will be what? In this case, the power associated here is nothing but what? It is nothing but 2 square by 2, that is 4. 2 square by 2, that is 2 only, right? Okay, you can say that px1 is nothing but 2, px2 is nothing but what? 16 by 2, which is 8, and px3 is nothing but 16 by 2, that is 8 only, right? So now you can find out the total power, px total power, right? The px is going to be what? 2 plus 8 plus 8, which is nothing but 18, and p rms you can find out, right? I mean x rms, sorry, square root of 18. So how fast you are able to find rms, how fast you are able to find power, that matters a lot, right? Okay, so condition is what? The condition is nothing but you have to make sure that, okay, the each sinusoids should have different frequency, right? Okay, and you have to check whether the given signal is periodic or not, right? So these kind of questions are very important. In this kind of question has already been asked in the GATE examination. So I can take one question also. It was asked in GATE 2013. Okay, just to show you. Okay, so don't take any concept lightly. Okay, but your concept should be clear. Okay, the concept should be always clear. Then only you can answer the question. Fine. So let me take this question. So what was this question, but guys? Question was from GATE 2000. Okay, 13. 1 minute. Let me take this. ये क्वेश्चन था आपको गेट 2013 में आया था. गेट 2013 for a periodic signal. Okay, so already they have said that it is a periodic signal, so you don't have to check. See, in the question if they have mentioned that the given signal is periodic signal, so you don't have to examine, you don't have to investigate that given signal is periodic or not, right? It will be periodic only, right? So, and you have to find the fundamental frequency in radian per second. Okay, so it is very simple. Okay, as same question as I have given you. So here the phase shift does not affect periodicity. So you can find out the omega naught. Omega naught is nothing but GCD of omega. This is nothing but omega 1. This is nothing but omega 2, and this is nothing but omega 3, right? So it is nothing but 100, 300 and 500. So I think the common factor is nothing but 100 only, right? 100 of 135, right? So the answer for this is 100, right? 100 radian per second. So how fast you can answer this question? 1 mark you got, right? So if you know the concept clearly, okay, if you will follow my sessions regularly on GATE crash course for electronics and electrical and instrumentation, सारे concept clear हो जाएंगे, क्योंकि I never give partial information, guys. I just want to give you complete information so that any sort of question you can get. Okay, तो आपका concept clear होना चाहिए कि if combination of sinusoids are given, all sinusoids should have different frequencies, right? तभी आप पावर्स को ऐड कर सकते हो, अदरवाइज पावर्स को कैसे ऐड करोगे? ठीक है, देन यू कैन फाइंड द आरएमएस. फाइन. सो दीज आर द इंपॉर्टेंट कॉन्सेप्ट दैट यू कैन रिमेंबर. So these are the concepts that you have to always keep in mind. Fine. So suppose you have got signal. Okay, suppose xt equal to sin pi t if it is given, right? Okay, so you can also say that sometimes ki this is almost periodic. Okay, almost periodic, sometimes we call it, or sometimes we call it what? Sometimes we call it aperiodic also, right? So in GATE examination mostly we talk about aperiodic only, right? अब जैसे मान लो क्वेश्चन में ऐसा दिया है, let me take one question. xt equal to sin 2t plus sin pi t. It is not periodic, right? xt equal to, you can say that sin 2t plus sin root 3t, not periodic. Okay, तो आपको चेक ही नहीं करना है, मतलब just by looking at the frequencies, if you take the ratio, it is not going to be rational, right? अब देखो रेशनल नंबर क्या होता है, आपको ये समझना जरूरी है. रेशनल नंबर की डेफिनेशन क्या होती है? रेशनल नंबर, राइट, ये बहुत इंपॉर्टेंट है. रेशनल नंबर इज नथिंग बट व्हाट? इफ एनी नंबर कैन बी रिटन इन दिस फॉर्म, रेशियो ऑफ p, you can say the rational number is nothing but ratio of integers, ratio of integer, right? Ratio of integers here, right? So p by q, where q should not be equal to 0, right? Okay, fine. Now but if you divide these p and q, right, if you divide these p and q, so you might get different types of decimal expansion, right? So based on decimal expansion also we claim that that number is a rational number, right? So how many types of decimal expansions are there? Decimal expansion, what is the meaning of decimal, guys? Any number is given if there is a decimal point in it, right? So जैसे मान लो 1.5, this is decimal point, there is a decimal point, right, after 1. So that number is a decimal number, right? So decimal expansion is there. They are two type of decimal expansion. One is called terminating टर्मिनेटिंग, व्हाट इज द मीनिंग ऑफ टर्मिनेटिंग? जैसे मान लो 1/4 है, अगर आप 1/4 को डिवाइड करते हो, वी कॉल इट 1/4 इज अ रेशनल नंबर, राइट? And if you divide 1/4, right, so you will get 0.25, and this number is after decimal point. There are some finite numbers, you can say finite digit, and that is terminated, right? So we call it terminating decimal expansion, right? So terminating decimal expansion will always be the rational number, always, okay? So 1/4 can be written as a rational number, understand? लेकिन अब कंफ्यूजन लोगों को यही आता है कि डेसिमल टर्मिनेटिंग है तो यू डोंट हैव टू वरी अबाउट एनीथिंग, राइट? बट सपोज समटाइम्स इट हैपेंस दैट मान लो 1/3 आप फाइंड कर रहे हो, 1/3 का मतलब 0.3333 एंड सो ऑन, राइट? सो इट इज नॉन टर्मिनेटिंग, नॉन टर्मिनेटिंग, इसको क्या बोलते हैं? नॉन टर्मिनेटिंग डेसिमल एक्सपेंशन, राइट? नॉन टर्मिनेटिंग डेसिमल एक्सपेंशन। लेकिन इसमें दो टाइप होते हैं, एक तो होता है रिकरिंग, राइट, रिकरिंग, एक होता है नॉन रिकरिंग। एक होता है रिकरिंग, वन इज रिकरिंग, वन इज नॉन रिकरिंग, राइट? सो व्हाट इज द मीनिंग ऑफ रिकरिंग, गाइस? Recurring means after decimal point that number will be repeated, or you can say that periodic will be there, right? You can say that 1/3 equal to 0.33333 and so on, right? Or 2/3 equal to 0.666. So you can write this as 0.3 bar, okay? This is called recurring. So non-terminating as well as recurring, okay? This is very important definition for rational number, right? So when you divide this, okay, so that should be like this, okay? तो नॉन टर्मिनेटिंग एंड रिकरिंग को हम लोग क्या बोलते हैं? रेशनल नंबर बोलते हैं, रेशनल नंबर। दिस इज आल्सो अ रेशनल नंबर, यू कैन से रेशनल नंबर, okay? You can write always 0.25 in the form of rational number, right? So non-terminating as well as recurring decimal expansion will give you rational number, but non-terminating and non-recurring is not we call it irrational, irrational numbers, right? You can say pi, root 2, root 3, okay? All these things, please remember this is very important concept, okay? So whenever questions will be given, right, मान लो क्वेश्चन ऐसा आता है कि xt इक्वल टू साइन √2t, okay, plus cos t. Now by looking at this, √2 is present, right? √2 is present मतलब make sure that this signal is aperiodic. आपको फाइंड करने की जरूरत ही नहीं है कुछ भी, पीरियोडिक नहीं है ये, क्योंकि एक फ्रीक्वेंसी आपकी क्या हो जाती है? इरेशनल। √2 इज अ इरेशनल फंक्शन, ठीक है? √2 is irrational. So if you take the ratio of this and this, here ω1 is √2, here ω2 is 1. So if you take the ratio √2/1, it is √2 only, and this is not the rational, right? So इसको बोलते हैं aperiodic. But few books are there, they also claim that they are almost periodic, you can say, but in our exam they will ask periodic or not periodic, that's it, right? So please remember this, fine. So what are the importance of harmonic signal? Why do we study harmonic signals? That is also very important to keep in mind, right? So why do we study harmonic? What is the importance of harmonic signals? Okay. Importance of harmonic signal. Okay, the very first importance is you have to remember, suppose xt is harmonic, xt is harmonic signal, or you can say sinusoids or exponential. Harmonic in the sense that what? Sine, cosine, e raised to power j omega t kind of thing, right? Okay, that you have to remember, okay? So if you will pass in future through LTI system, right, that is called linear time invariant system, okay? In future I will discuss linear time invariant system. So if you will pass sine, cos, e raised to power j omega t, whatever, so in the output you will get same sinusoids only, having same frequency also, right? That is the very important statement, okay? So response of linear system to a harmonic input is what? Also harmonic signal at input frequency only, right? Okay, at input frequency. अगर LTI system है तो sin omega t if you are giving to the input, output will be also sin omega t. There can be some difference in the amplitude, you can say. The amplitude can get scaled as well as the phase can be added, okay? That is the very important thing, and this is this forms the basis for system analysis in frequency domain, right? So in frequency domain, if you want to analyze the system, so you always give what? Exponential, right? Exponential. So here, suppose they have kind of, you can say that omega naught is the frequency of this, right? So output will also be having sine, cos, e raised to power j omega t. Okay, they will be having same frequency, but some, you can say some k can be multiplied here, right? K and phase can be added also, right? Okay, that is very important to keep in mind. Okay? So this property is also known as, suppose you are giving e raised to power j omega t to the LTI system. Okay, so this comes out to be k times e raised to power j omega t, right? So this k is nothing but we call it eigenvalue, and this is nothing but we call it eigenfunction. This is nothing but eigenfunction. Why eigenfunction? Because you are giving e raised to power j omega t to LTI system, and it is just giving you what? The constant times the same input, okay? Same frequency. Understand? This is the property of LTI system. How does your LTI system respond when you give exponential, when you give sinusoidal? ओके, सो ये सारी चीजें आपको पता होनी चाहिए जब आप नेटवर्क थ्योरी पढ़ते हैं कि कोई अदर सब्जेक्ट पढ़ते हो, तो ठीक है, इट्स अ वेरी इंपॉर्टेंट थिंग. ओके, एंड एनी सिग्नल कैन बी रिप्रेजेंटेड बाय कॉम्बिनेशन ऑफ हार्मोनिक्स, लाइक periodic ones you can say by harmonic at a discrete frequency, and aperiodic ones by harmonics at all frequency, right? तो ये भी important है, ठीक है. तो कोई भी सिग्नल होगा उसको हम लोग कॉम्बिनेशन ऑफ हार्मोनिक्स में लिख सकते हैं, राइट? ओके, so this is very important. Now let us talk about commonly encountered signals. Okay, what are the signals that we are going to encounter? Commonly encountered, okay, commonly encountered signal. Okay, commonly encountered, or you can see standard signals. Standard signals. Which are going to be useful in control system also, right? Like unit step function. Okay, unit step function is there. Okay, so I'm just going to write the definition of them. That's it, right? So the very first definition that I will be writing here is this. Okay. So you just remember the former definition of them. Okay, just I'm going to write, these are the commonly encountered signals. You see here, we call this as unit step function, right? What we call it? Unit step function. Okay, this is very, very important. Okay, and it is not defined at t equal to 0. It is not defined at t equal to 0. If you plot this guy, so the approximated one is this, right? This is approximated one, guys, not actual one, right? Because whenever something is 0 here, right, you can say it cannot be suddenly 1. Okay, so this kind of step we use in case of transient also, right? For switching case. Okay, okay, when switch is closed at t equal to 0, we call it unit step function. What we call it? Unit step function. Okay, so this is very, very important to keep in mind. Okay, this is very, very important to keep in mind, right? So you remember that here t should be greater than 0, is strictly greater. Sometimes many people they put here the equal sign also. So ये former definition आप याद रखना, ठीक है? और this is a graph, okay? But it is not t equal to 0 में ये 1 नहीं है, याद रखना, right? Okay, but one guy was there, his name was Heaviside, right? So what Heaviside did is, Heaviside said that u of 0 equal to 0.5. Okay, see, this function is not defined at t equal to 0. Okay, but Heaviside came into picture and he said that u of 0 is going to be 0.5, right? Okay, so along with this definition, if you say u of 0 is 0.5, so we call this as Heaviside function also. Heaviside function. Okay, Heaviside functions. Okay, or you can say Heaviside unit step function. Okay, unit step, Heaviside unit step. Okay, that is very, very important to keep in mind. So, and the second is nothing but ramp. Okay, we call it ramp. This is ramp. Okay, ramp, and this is nothing but a signum one. signum function or a signal you can say, right? You see, for t, for positive time it is 1, for negative time it is negative, right? So you can say that if you want to plot it, right? So let me plot. देखो स्टेप आपका कैसा दिखता है, कुछ ऐसा. Ramp will look like this. Okay, this is ramp r of t, we call it u of t, right? And your signum function will look like this, you know, for time t positive it is gonna be like this, plus 1, and for this it is negative 1, right? So this is nothing but a signum of t. Okay. And signum of t is also very important, right? So you can also write this in terms of u of t, right? In terms of u of t. Okay, तो ये तीन सिग्नल्स हैं, तीन फंक्शंस हैं, आपको याद रखना है, राइट? सो apart from that sinusoids, okay, sinusoids are very important, right? Okay, when you, because there is a property, you know, exponential has some sort of property if that is a complex sinusoid, like e raised to power j omega t. If you give e raised to power j omega t to the LTI systems, it will give you same output, right? Scaled version of same input, right? Scaled version, I mean the amplitude is going to get scaled, right? Okay, so several other signal models are important, right? You can say unit step ut, unit ramp, we call it signum function. Okay, and these guys are what? These are piecewise linear signals. Okay, we call them as piecewise linear signal. इनको सबको क्या बोलते हैं, याद रखना, piecewise linear signal. Okay, piecewise linear signal, what we call it? Piecewise linear signals. Okay, it is very very important to remember, these are piecewise linear. Okay, we call it, understood? So piecewise linear, understand? This is very very important to keep in mind. Okay, so in general you can say that in general, as we define ut is what? Ut is nothing but for t greater than 0 it is 1, for t less than 0 it is 0 strictly, and with heavy side we can say this is nothing but 0.5. as we can say mathematically, you know that that is discontinuous at t equal to 0, right? But in signal and system, as you know, heavy side suggested that you can take u0 equal to 0.5, that is average value, average, understood? Okay, wherever the discontinuity happens, so you can always find u of 0, right? That is 0.5, understood? Discontinuity means all of a sudden, you know, your signal is becoming from 0 to 1, right? So that is very important to keep in mind. Suppose you say that in general, u of ft, is what? What is the definition of u of ft? In this case also you can say that if ft is greater than 0, if your function is greater than 0, u of some function, so it is going to be 1, and if ft is less than 0, so you can say it is 0, right? So definition is going to be same only, right? Definition is going to be same. Okay, these definitions are very very important definitions that you have to remember. Okay, so let us go ahead. So these are the definitions that you have to remember, guys. Okay, fine. And there are some relations also you can talk about, like these are the three basic integral, right? So you have got unit step, you have got ramp. So from the ramp you can also get you know, suppose you have got unit step, right? Suppose you have got ramp, let's say ramp. Okay, so how can you get unit step? So you can differentiate ramp, right? So if you will differentiate ramp, you might get unit step, right? तो ये भी याद रखना, ये बहुत important होता है, right? So suppose you have got a ramp signal, you know, t rt equal to what? tut, we write tut. Okay, understood? So tut, why ut is multiplied here with t? Because the signal is defined for positive time, right? So ut, अगर मान लो कोई signal given है, if any signal is given, if it is multiplied by ut, so that signal is nothing but one-sided one, right? You can say right-sided. Okay, or that signal is defined for positive time whenever ut is multiplied, and whenever this ut is multiplied, that signal become non-periodic. I mean, it will never be periodic. Okay, because that is switched one, right? It is only defined for positive time, right? But what is the meaning of periodic signal? It should be everlasting. everlasting मतलब माइनस इन्फिनिटी से इन्फिनिटी तक डिफाइंड होना चाहिए, ठीक है? Fine. So R of t is going to be what? R of t is tut. So if you differentiate this, it's ut is going to be what? R dash t. Or you can also write this as dy by. Okay, this is the definition. So suppose you have got unit step, and how can you get the ramp? So you can get ramp also, right? So R of t is nothing but minus infinity to t, right? Minus infinity to t, u of tau d tau, u of tau d tau. This is ramp of t, right? Ramp, okay? R of t is going to be u tau d tau, okay? So this we call it running integral here. This is running integral, okay? Your integral is running from minus infinity to t, okay? Minus infinity to t. You can also write 0 to t, right? 0 to t, because u of t is defined for 0 to present time, or you can say, right? So it is nothing but 0 to t or minus infinity to t. Okay, this is very, very important to keep in mind. Fine. So these are some commonly encountered signals that you have to remember, okay? So these statements also you have to remember. What I said was unit step, okay? Unit step, ramp, signum functions are piecewise linear. What we call it? Piecewise linear. You see, there is a piece, okay? Piecewise. Why we call it piecewise? Why we call it piecewise? Because you can see here there are different expressions, right, for different time instant, right? From minus infinity to t, infinity to 0, you can say it is going to be 0. From 0 to infinite, it is 1, right? So there are different expressions, you can say, right? So this is important case that you have to, this is signum function, you can see here, okay? Now signum function can also be written like this, signum function can be written as, this is defined for positive time t. So you can say that this is u of t, and this is nothing but minus u of minus t, you can say. If you take ut and fold it, okay, and then subtract it, so you will get this only, okay? So you can also write this as ut minus, you can say that this is nothing but this can be written as 1 minus u of t. So if you take this, so it is nothing but 2 ut minus 1. Right? So sometimes this is also very important, right? You are able to express this signum of t using 2 ut minus 1, right? So in future you will study about Fourier transform and all, right? Fourier transform and all. So this will help you, right? So if you know the signum of the Fourier transform, right? So you can find out the ut Fourier transform, right? And if you know ut Fourier transform, you can find signum of the Fourier transform, right? So in this manner you can just find out the Fourier transform, right? तो ये सारी चीजें हैं, आपको याद रखना है. Next comes out to be the pulse signals, right? Okay, and there are two pulse only जो हम लोग standard use करेंगे. We will call it pulse signals. Okay, pulse signals. After unit step and ramp, okay, we will get the pulse signal. There are two kind of pulse signals. One is called rectangular pulse, one is called triangular pulse, right? So rectangular t, rect of t, rect t, we call it rectangular function. It is defined as, remember that it is defined for 1 for mod of t less than 0.5, okay, mod of t less than 0.5, and it is 0 otherwise. Okay, it is 0 otherwise. Okay, please remember this. So this is called pulse signal, rect, okay, rect t. Okay, so how do we represent this? Between minus 0.5 to 0.5, it is nothing but 1. This is going to be a rect, and this is one of the very useful pulse signal used in case of digital communication as well, right? So it is very important, okay, pulse signal, okay, and it has got huge application in digital communication, okay. आपको याद रखना है हमेशा कि हम लोग हमेशा क्या करते हैं, स्ट्रीम ऑफ बिट को वी ऑलवेज मैप टू वन ऑफ द वेल डिफाइंड पल्स, दैट इज नथिंग बट रेक्टेंगुलर pulse we use. Okay, and you will understand the importance. So sometimes people can ask you what is the importance of using this pulse signal. ठीक है, तो ये सब आप याद रखना. Fine. So let's move ahead and talk about okay. तो ये आप याद रखोगे. और एक होता है आपका ट्रायंगुलर, राइट, ट्रायंगुलर. सो ओके, दिस इज वेरी इंपॉर्टेंट. सो अगर हम इसको जनरलाइज करें, रेक्ट टी को, तो हम लोग कैसे लिखते हैं, ए रेक्ट टी बाई कैपिटल टी. ओके, ये ए क्या है आपका, एम्पलीट्यूड हो गया. टी क्या है आपका, टी इज नथिंग बट ड्यूरेशन ऑफ द पल्स, यू नो, द विड्थ ऑफ अ पल्स. ओके, दिस इज नथिंग बट विड्थ. This is nothing but amplitude, you can say, right? Amplitude. So how do we define this? This is defined, you can say A will be there for mod of t less than, you can say, t by 2, okay, and 0. So if you want to plot this, so whenever there is a t, so always divide by 2. Okay, always divide by 2. So this width is nothing but capital T, and this strength is going to be A, right? Height is going to be A. So this A is nothing but a height of a pulse. This, you know, A is nothing but a height of a pulse, you can say. Okay, so you have to know height of a pulse. You have to know area of a pulse. You can find out. Okay, area of a rectangular is what? Just, you know, height into width, right? Okay, and the width. That's it. Sometimes we also call it, you know, a pulse signal also considered to be called as windows. Okay, windows to any arbitrary signal, you can say, right? So if you take any signal xt, multiply with the rect signal, okay, so that will be what, that will make your signal in windows, right? Okay, that will be time limited then. Okay, time limited signal will be there, right? Time limited. Okay, it is defined for some particular time, you can say. Fine. So this is the case. Suppose you have to draw here. Suppose let me draw here 2 rect t by 4 को हमें draw करना है. How can we draw? We can draw here. This is nothing but it is, signal is defined from -2 to 2. Okay, and then the height is nothing but 2 only. Suppose somebody is asking what is the area of this. Area is going to be, the width is 4, the height is 2, so 2 into 4, which is 8. In fact, you can also find the area directly. This is nothing but height and this is nothing but width, right? Because this is nothing but height. So if you want to find the area, area is nothing but height into width, 2 into 4. Okay, so in this manner you can find out the height and the area. So this is one pulse which is called rectangular pulse. Okay, next is called as triangular pulse. Okay, and triangular is very important because in case of communication system also, like, you know, we'll talk about triangular density function, right? So triangular pulse is very important. So a tri t by capital T, suppose it is written like this. Okay, so how it is defined, always remember, this is very important. It is defined like it will be a, okay, it is going to be a times t minus mod of t by capital T, right? Mod of t by capital T, otherwise it will be 0, you can say. Okay, otherwise it is gonna be 0. Okay, so there will be two cases. Okay, there will be two cases. So it is defined only for, you can say, mod of t less than capital T, right? Less than capital T. Okay, less than equal to, you can say, capital T, otherwise it will be 0. Okay, otherwise, so this is the very good definition that you can see. So when this signal is gonna be 0 at t equal to capital T as t equal to minus capital T both, right? So how do we plot this? Remember that this time, this is not the width, guys, not a width, you can say, not a width. It is not a width, you can say. Okay, this is not a width. Okay, this is not a width. It is just, you can say, here the signal is gonna be 0 at t. Okay, here the signals are going to be 0, you can say. I'm just writing like this. This is minus, this is t. Okay, so situation will be looking like this. Okay, you see here at t equal to 0, it will be a. Okay. So always remember, whenever a try t by capital T is given, so you can quickly draw it like this. Okay, you can quickly draw it like this. Okay, and the width here is nothing but what? The width is 2t now. Okay, the height is nothing but a. So whenever you want to find the width of this a try t by t, so you multiply by 2. Okay, multiply by 2. So suppose I want to plot here, 2 try t by 4. So what will be the plot of this guy? So plot is going to be like this: -4 to 4, and this is 2. Right? Okay, so if you try to find the width here, so width is going to be 8. Right? So I hope this makes sense. So you can find out the area. Area of the triangle is what? Area of the triangle is nothing but 1 by 2 width into height. That is going to be 8 only. Okay. I think this is clear for all, right? So you can just do like this. Okay, you can just do like this. Okay, this is how we find out the okay. Yeah, fine. So here you can see this this is very important concept. Okay, this is very important concept to understand. Suppose we have got try t, a triangular pulse t. So it can be written as what? It will be 1, okay, time, it will be nothing but what? It will be nothing but 1 minus mod of t, okay, because here capital T is nothing but 1, okay, for, okay, and 0 otherwise. Okay, so how do we plot this? It is going to be from -1 to 1, and the magnitude and height is 1 here, right? What is the width here? Width is 2, and this is nothing but what? This is nothing but, you can say, the height is 1 here. Okay, so what is the area here? Area is going to be 1 by 2 into 2 into 1, which is 1. Okay, so this is how you can find out. It is very useful. It is very useful. Please remember this. Okay, and these pulse have got the even symmetry, guys. This is also very important to keep in mind. These pulse has got even symmetry. If you put xt equal to x of minus t, so they will not change, right? Xt and x of minus t is gonna be same. So this is very important, right? So you have to remember this. Okay, you have to always remember this. So any arbitrary signal may be represented in the form of you can say each of which in different forms, and each of which has its advantage depending upon the context, right? For example, we will find signal description by interval, okay, quite useful in convolution, right? Whenever we will talk about convolution concept, okay, so that is very important. So you have to remember this line. Let me put this line in the notes as well, so you guys can remember this. Okay, so where do we use this? What are the importance of these signals? तो ये याद रखना आप लोग हमेशा, ठीक है? So an arbitrary signal may be represented in different forms, each of which has its advantage depending upon the context. For example, here we will find signal description by intervals quite useful in convolution, right? A description by linear combination of shifted steps and ramps very useful in Laplace transforms, okay? And description by linear combination of shifted rect and triangular functions extremely useful in Fourier transform. So sometimes what will happen here is we have got some sort of a signal, right, and we have to find the Fourier transform, right? So you can easily find out Fourier transform by writing the linear combination of what? Shifted version of unit step as well as triangular pulse, whatever. Okay, so always understand what are the importance of these elementary signals which we encounter in our day-to-day life. आप लोग यूज तो करते हो, मान लो कोई सिग्नल दिया है, उसका फोरियर ट्रांसफॉर्म निकालना है, यू ऑलवेज ट्राई टू graphically find out the Fourier transform, right? But you don't know why you are doing, right? So these are the reasons, because you know pulse, a basic pulse you know. Now using that pulse you can construct any pulse, any different kind of arbitrary signal you can construct, right? You can add two pulse, you can add, you can say you can subtract rectangular as well as the triangle, right? Okay, understand. So these are the concepts that you have to remember always, right? Okay. So you can try all those operations that I have told you, right? Suppose you have been given u of t and now you have to find u of 1 minus t, okay? Or in case of rectangular also you can play, okay? You can play around and you can do it, okay? So that is very simple to do. And why I'm telling this, because they might give you the question, okay? So let me take one very easy question. Suppose you have to find, suppose you have to find what? Suppose you have to find triangular, okay? Like, suppose you have to sketch, in fact, yt equal to triangular 1 by 3, okay? 1 by 3 t minus 1. Okay? You have to plot this. Sometimes what they do is they give you some periodic signal and they ask what is the power of this signal, right? Now you might get disturbed. Oh my god, okay, what is this? Okay, suppose they ask you what is the energy of this signal, right? Suppose it is not a periodic signal. What is the energy of the signal? See, whether the signal is periodic or not periodic, right? We always find energy, right? If signal is not periodic, means it will be a and the signal is finite duration signal having finite amplitude, right? So you're going to get the energy, right? So you will find the energy. For periodic signal we always find the energy in one time period, right? So everywhere we find out the energy only, right? And then we divide by the time period. Understood? So in this case, if you want to find the energy of this signal, so this shift does not affect anything, right? This shift does not affect anything, you see? Okay, so how do we plot this? How do we plot this guy? Okay, so here what are the things that has been done, that you have to remember. So signal xt equal to what? Triangular 1 by 3 t minus 1. Okay, so what has been done here? So forget about first what this the scaling, right? Forget about this scaling, right? Let me this scaling, just forget about that, right? Just forget about this scaling. Okay, what you do first, find out, suppose you know triangular of t. Triangular of t is nothing but what? It has got -1 to 1, right? And this is nothing but, you can say, 0, right? Sorry, not 0, I've written wrong, right? It is 1. Now you shift it, right? So you can say that it is gonna be shifted t minus 1. Okay, you can shift it, right? So let me shift this guy. So if you are going to shift, so क्या आ जाएगा ये? You can add here, so it will be nothing but the situation will be like this. It is nothing but 0 and it is 1, 2, right? Okay, but in this situation this 1 by 3 is common to all, right? Common to all, you have to remember this. Okay, so what you can do here is first of all you can write this as triangular. Okay, so this is the normal thing that I am doing, right? Okay, but you should know the triangular of t, that's it. If you know the triangular of t, you can find out this. Okay, you have to sketch. स्केच बहुत इंपॉर्टेंट होता है, ठीक है? तो इसमें क्या लिखते हैं? दिस इज नथिंग बट 1 by 3 t minus 1 by 3, you can say, right, like this. Okay, so or what you can do here is, or you can say that you can go by definition also. I don't have any problem, right? So if you go by definition, you can try this. Okay, so this is very important signal where you have to draw it. Okay, where you have to draw this triangular 1 by 3 multiplied by t minus 1, right? So here what will be there, let me tell you directly. It will be stressed triangular pulse of a bit 6. Okay, the bit is going to be 6 here. Okay, the bit is going to be 6. इसको आप कैसे लिख सकते हो मैं आपको दिखा देता हूँ. इट्स अ वेरी सिंपल कॉन्सेप्ट, राइट? ठीक है, तो इसको आप ऐसा लिखो, ट्रायंगुलर t minus 1 by 3. ये लो. So you don't have to worry about this, right? It's a very simple concept now, right? So since you have got this, okay, so what you can do here is, first of all, you try to plot this. Okay, try to plot, okay, then you just shift it. If you are going to plot this, so it is going to be plot from -3 to 3, right, and 1. Now what you can do, this is nothing but what? this is triangular T by 3, right? Now you shift. Okay, so what you're shifting? You're shifting time, right? So if you want to get triangular T minus 1 by 3, so you can say that इसको कैसे करेंगे? +1 +1, so it has got shifted, you can say. So this is -2 and this is 4 at 1 now, right? So this is the signal. This is the signal that is being asked, right? Okay, so it is centered at what? At t equal to 1. It is centered at t equal to 1, you can say, right? I think this is clear. So whenever, suppose, let me take one more question, by t equal to in case of rectangle, right? In case of rectangle, you can say rectangular 0. You can say rectangular t minus 1 by 2. So can you plot this? You will say yes sir. कैसे? देखो, first you do what? You plot this -1 to 1, then you shift by 1, right? So it will be nothing but, you can shift by 1 to the right. Okay, so it will be from 0 to 2. Okay, so this is what they are asking. Okay, now, so always remember, in general what you have to remember is, suppose they are saying that ft equal to rectangular t minus beta by alpha. Okay, you can plot this. So it is nothing but, first you plot this, okay, from minus alpha by 2 to alpha by 2, then you shift by beta. So the shifting will happen like this, you know, just you have to add here the beta. So it will be nothing but minus alpha by 2 plus beta, and this is alpha by 2 plus beta. Okay, and this will be at beta. Centering will be at beta, right? You can say. I hope this makes sense. So इसमें बहुत सारे लोग कंफ्यूज होते हैं, तो याद रखना, if ft is given as rect t minus beta by alpha, सबसे पहले आपको ड्रॉ करना है रॉ. Forget about this shift. Forget shift. Okay, just forget about this shift. Okay, understood? In the beginning. Plot shift by beta. Right shift, you can say. मान लो ये इन जनरल मैं बता रहा हूं, क्योंकि इसमें सब लोग कंफ्यूज होते हैं, राइट? जब भी रेक्टेंगुलर t माइनस बीटा बाई अल्फा आएगा, तो आपको क्या करना है? सबसे पहले आपको सिग्नल ड्रॉ कर लेना है सिंपली, राइट? ओके, दिस इज वेरी इंपॉर्टेंट टू कीप इन माइंड. और सेंटर आपको कहाँ रहेगा? बिट, आप you will be getting a width alpha only, right? Width is not going to change here, and center will be at t equal to beta, right? Okay, in this, so you can remember also, in this case center will be changed, right? Center will be beta and width will be alpha only, right? Okay, now in case of triangular अगर बात करते हैं, suppose we have got gt equal to triangular of t minus beta by alpha, right? You might have seen in the beginning, when I was telling you, I was also confused, okay, but somehow I managed to tell you correct, okay. So this happens with everyone, okay, because I don't have any notes, I just follow, just whatever I know, I'm just telling you, right? So you have to follow this, right? So triangular t minus alpha by, t minus beta. So this beta is nothing but what? This is nothing but a center, you can say. Center is going to be beta. And what is the width, guys? Width is going to be 2 alpha. Okay. Okay. So this is very important to keep in mind. I hope this makes sense. So suppose any signal is given, right? Suppose you can say that xt is given, okay, and equal to st. So if you multiply this st by rect, what will happen? You can say that this st will be what? St abruptly truncated, okay? Your st will abruptly will be truncated, you can say, right? मतलब ये truncate हो जाएगा, okay? Suppose st is like this, you can say. But if you multiply with rectangular like this, what will happen? This guy will become like this only. Within this, okay? Everything is gonna be 0, okay? You can say that st got truncated, okay? Within this, you can say it is nothing but minus 0.5 to 0.5. So your signal becomes 0.5 to 0.5, okay? Time limited हो गया, ठीक है? Your ST will be having the same shape, don't worry, right? ST will be having the same shape, but it will be truncated by, abruptly truncated, you can say. Abruptly. Truncation will be there. And suppose xt is given, right? And you are multiplying st by triangular of that. So in this case, what will happen here is that your st linearly tapered, okay, about t equal to 0. Your st is gonna be linearly tapered, right? Linearly tapered, you can say. This guy will be linearly tapered, okay, about t equal to. What is the meaning of linearly tapered? Your triangular looks like this now. It is what? Linearly tapered only, right? Here it is linear only, right? There is a slope, negative slope and a positive slope, right? So ये सब याद रखना, right? That is very important. And 0 will be after t equal to 1, right? Minus 1, minus and plus both. Okay, so please remember this. This is very important to keep in mind. And yes. So these are the things, guys, I wanted to talk today, right? So in the next session, what I am supposed to talk here is, आप लोगों को ये सब याद रखना है जो बेसिक सिग्नल मैंने बताए हैं, whatever basic signal I told you, right? Okay. If you remember these, in the exam they will ask questions, okay? तो आप लोग इसको याद रखो, pulse signals, okay? Unit step, periodic जो मैंने बताया आपको, right? And then I'll talk about in the next session sync function, right? और sampling function, वो भी बहुत इंपॉर्टेंट है, ठीक है? Sync function, or sometimes we call it sampling function, okay? Sync function is one of the very important, right? Or sync square function, right? And then we'll talk about impulse function, right? Impulse as a, you can say, limiting representation. We'll see how we will get impulse from the limit, okay? Like any generalized function you take, and then any function you take and then apply the limit, and you try to get this impulse. Then we will see the relation between impulse and the step, okay? And then we will also see how we differentiate, okay, at discontinuity, right? Suppose u of t is there, right? So can you differentiate that u of t? Okay, so derivative of signal with jump. Jump means if there is a 0, all of a sudden abruptly it became 1, right? Step function. So we will see the derivative of signal with jump. That is very important. Okay, we have to understand. Then we'll talk about different properties of impulse. Okay, product property, shifting property, right? Scaling as well as product shifting, okay, of the impulse function. Okay. And then we will try to approximate signal by impulses. Suppose any signal is given, we can approximate it with the help of impulse, right? Okay. So that is nothing but what? Suppose continuous time signal is given, right? If you multiply impulse train, right? So your signal will become what? It will become a sampled version of the continuous time signal, right? That is called sampling also, right? So we'll see that how we can approximate signal approximation by impulses, okay? And then we will talk about derivative of impulse, which is known as doublet. Okay? And there are some properties of doublet also. So that we will see, like scaling, product, as well as shifting property of doublet. And then we will talk about moments. Okay? So this chapter will be over. So one more session on continuous time signal, guys. Okay? One more session I will dedicate. Then I'll start discrete time. Okay? Then I'll start discrete time. तो आप लोग ये सारे फोकस करो और एप्लीकेशन इनका समझ लो कहाँ पर है, राइट? मैंने आपको साइनसॉइडल के बारे में बताया कि साइनसॉइडल अगर आप एलटीआई में दोगे, इफ यू आर गोइंग टू एम्प्लॉय to if you're going to give to LTI system, so output will always be sinusoidal only with same frequency. Input frequency will be same. अगर मान लो different frequency है, then that is not the LTI system, right? So please follow that. We will meet very soon. Okay, so keep following these gate crash course. Certainly you will get complete marks. Okay, like you will get all the questions from my gate crash course, that I can guarantee, if you're going to follow me, right? Thank you.